So let's continue our Feb-March 2018 paper with question 5. So we have parametric equations. We have that are basically equations of x and y in terms of another parameter, in terms of another variable rather, that is t in this case. And you're given the range of values for t, and you have to calculate dy over dx and show it to be a particular to be this particular expression. Okay, so to calculate dy over dx, you basically, if you think about this, this is dy over dt divided by divided by dx over dt. Now maybe I've written it a bit well, it's a little messy now that I write it, but the idea is this: dy over dt is dividing by dx over dt. Dt and dt cancel out to give you dy over dx. So if you want to figure out dy over dx, you simply calculate dy over dt and dx over dt and just divide them. So that means basically you're going to be differentiating with respect to t first, at least. So dy over dt, calling your attention to this particular equation, the differential of 1 is just 0. The differential of cos 2t, now minus 2, let's just write that. Of cos 2t, the differential of cos is minus sine, so minus sine 2t. And if you remember what you have inside the bracket, what you have as 2t, the differential of that is multiplied. So the differential of 2t would be 2. So that will also be multiplied, giving you a dy over dt value of plus 4 sine 2t. Correct? And now you want to calculate dy over, not dy over dx, too soon for that, dx over dt. So differentiating the equation that you're given here. Now the differential of 2t is simply 2. The differential of sine 2t is cos 2t into 2, which gives you 2 plus 2 cos 2t. Again, the reason why I'm doing into 2 is because this has to also be differentiated and added and multiplied. That's the idea. It's multiplied in differentiation and divided in integration, which is what we did earlier in this particular video as well. There was a question where we did that. Now you want to divide this and this. So you want to be dividing dy over dt over dx over dt, so that dt and dt can cancel out to give you dy over dx, which is simply 4 sine 2t upon 2 plus 2 cos 2t. However, they want us to show that it's in a particular form, and for that we're going to apply some particular properties, trigonometric properties. Now if you see, it's tan t, so they want you to take this in single angle. Now you can check this from the MF9 table as well, but sine 2t would be sine 2 sine t cos t. Now it's interesting. Now with cos 2t, you can have a variety of formulas. You do have a variety of formulas. You can have cos square t minus sine square t. You can have 2 cos square t minus 1, and you can have 1 minus 2 sine square t. How do I know which particular property to use? And it's simple. Look at the question. Look at what you're trying to achieve. You're trying to achieve 2 tan t, which means by tan you want to have some form of sine upon some form of cos in order for it to simplify into and go into tan, right? Another way to look at this is, for this to happen, you have to ensure that there are no plus ones or no 1 minuses in the denominator. And currently you do have a 2. You do have this. You want to get rid of this. You want to put such a formula in here that it ensures that your plus 2 gets cancelled out. And that only works where if you use 2 cos square t minus 1, because if you had the minus 1, it can then cancel out the plus 2 that is here. This plus 2 I'm talking about. This is an annoying plus 2 because it prevents us from doing any simplification with the numerator and the denominator. So if that made sense to you, the formula we will use is 2 cos square t minus 1. So 2 cos square t minus 1. What happens then? You have 8 sine t cos t, and below what's happening is what I was talking about. So 2 plus 4 cos square t minus 2. Now this minus 2 is something that we needed to cancel the plus 2, and the reason why we needed to cancel the plus 2 is then when you don't have any plusing or minusing going on in the numerator or the denominator, whoopsie, then that's when you can actually start to do some simplification between the denominator and the numerator, which is why I wanted to get rid of the 2, which is why I used this particular formula for the double angle of cos. So cos square cos t, and 4 1s are 4 2s are. So you have 2 sine t over cos t, which is the same as writing 2 tan t. Another reason why I wanted to use the property that'll give me cos in the denominator, because sine over cos eventually gives you tan, and that's exactly what we wanted to prove. So this is good. Hence, find the x coordinate of the point on the curve of the point on the curve at which the gradient of the normal is 2. Give your equation answer correct to 3 significant figures. Now, if we quickly copy what we've worked out in the previous answer, which was the gradient of, which is basically dy over dx, is 2 tan t. Now, this is basically testing a concept that we use a lot in AD math and AS math. This is basically your gradient. Dy over dx represents your gradient of tangent to the curve at a particular point. The gradient, the normal, is always going to be perpendicular to the tangent. So if it's like something like this, let's say this is your tangent, this will be your normal. This is going to be your normal, which means your normal and your tangent are going to be perpendicular. Now, what do you do with perpendicular lines? You can use the formula m1 into m2 is equals to minus 1. So, which is basically the gradient of one of the perpendicular lines into the gradient of the second perpendicular line should be equals to minus 1. So the gradient of the normal is 2, that's given in the question. Into m2 will be the gradient of the tangent. We do not know that, but we can calculate it like so, minus 1 upon 2. This will be equals to our dy over dx, because our dy over dx gives you the gradient of the tangent. Another way to remember this, if you don't want to remember the formula, is just simply take the negative reciprocal. So the reciprocal of 2 is 1 upon 2, and just add a negative sign. Just change the sign for that. So that's another way you can remember the relationship between the gradients of perpendicular lines. So just pop this into the equation. Minus 1 upon 2 is equals to 2 tan t. Okay, and that gives us tan t is equals to minus 1 upon 4. Now we have to solve for t. So a few things that are important in such questions. Do look at the English they've used. I know it sounds funny, but this just really helps. They're talking about the x coordinate. So means they're looking for a single solution. So if you're getting more than one solutions, you're either doing it wrong, or you either did not look at the range of values that's given. The range of values of t that's given is basically from minus 90 to 90. Pi by 2 to minus pi by 2. So those are the range of values that we have given. Now, if you look at this, add sugar to coffee, this can't be it. Like the range of values are like pi by 2 to minus pi by 2, which means only these two quadrants are really in consideration. However, the issue is the first quadrant cannot be it, because, well, all trigonometric functions are positive there. This is clearly a negative. It is negative in the fourth quadrant. Here we'll be using what we call your clockwise rotation, where you get a negative angle, a negative value of t basically. So whatever we get the basic angle, your basic angle is going to be the value of t in the fourth quadrant. So let's try to work that out. The basic angle is going to be tan inverse minus 1 divided by 4 in radians. Tan inverse gives you minus 0.245. Right now, normally we ignore the minus sign when it comes to your basic angle. You want your basic angle to be positive. So that's just what I've done. And now what you want to look at, if I just draw this again, your basic angle is the angle that it makes from the positive x-axis, which is this. And when you're going clockwise, you're kind of going in the other direction as opposed to going anti-clockwise. This is anti-clockwise. This is clockwise. Now, so if you're going clockwise, as you can see here, your value of t will be what your basic angle is, which is 0.245. However, one thing to note, since you are going clockwise, in clockwise rotation, like if you're going anti-clockwise, this is donated by a positive angle. If you're going clockwise, this is donated by a negative angle, just to signify the direction of your rotation. This is going to be negative 0.245. That is your value of t. But however, they don't want the value of t. They want your x coordinate. That's important. So they want your x coordinate. They're not your value of t. What are you then going to do? You're going to pick up this particular equation. You're going to input your value of t. That is, it was coming to be minus 0.245 plus sine 2 into minus 0.245. Through this, you should get your value of t. So let's quickly calculate. Let me just in fact use my calculator. And the value of the x coordinate you're getting is minus 0.961, rounded off to 3 significant figures, because that's what you do anyways. But if they have specified in the question, then you would definitely have to do that. That's the level of accuracy you have to give your answer to.